Hey guys, so that was my favorite song by DJ Snake. It's called Middle. And the reason why I picked that song today is because we're going to be looking at what is the middle of a triangle. That's basically the essential question. And it turns out that there are four middles or centers of triangles. There's the incenter, circumcenter, orthocenter, and centroid. And then we're going to look at the implications of what those centers mean in terms of the triangle. So we're using the same notes sheet from 5.6 in this unit as well. So we're going to be mainly focusing on the right column this time around. So the first thing that you're going to put down, put it in like an extra box because it doesn't really have anything to do with segment midpoints. And it's called the point of concurrency. Kind of the only thread here is that it's a point, just like a segment midpoint is a point. And so the point of concurrency, or the POC, is a point where three or more lines intersect. Okay, so it's basically like the point of intersection for three or more lines. Okay? So last section we talked about medians, and a median goes from the vertex to the midpoint on the opposite side. And so it turns out that the three medians of a triangle are concurrent. There's a point of concurrency about them, and so that's point M. And so the point of concurrency of three medians is called the centroid. So point M is the centroid. And the centroid is twice the distance from the vertex as it is from the opposite side. So in this case, the length of AM is going to equal twice the length of MX. It also turns out that the centroid is the center of gravity. So like if you had a triangle and you had to like hold it on on a pin, that the triangle would perfectly balance on the center of gravity, at the centroid. So where the three angle bisectors meet, it is called the incenter. So this point would be the incenter. Okay, so it's the point of concurrency of three angle bisectors. Okay, and also the incenter is the center of the incenter is the center of triangle's inscribed circle. So an inscribed circle is a circle that perfectly fits inside the triangle. So that means the three sides of the triangle just lightly touch the sides of the circle. So the incenter is the center of the inscribed circle. It is also equidistant from each side of the triangle. So if I drew a dotted line, that distance is the same as that distance, which is the same as that distance. So, because remember, the distance between a point and a line is perpendicular to it. So we can tell that we can use that the incenter is equidistant from each side of the triangle. Perpendicular bisectors, so the perpendicular bisectors also are concurrent. They meet at a point of concurrency, in this case there. And it's called the circumcenter. So the circumcenter is the POC, or the point of concurrency of three perpendicular bisectors in a triangle. The circumcenter is the center of the triangle's circumscribed circle. So an inscribed circle is a circle that fits perfectly inside the triangle. A circumscribed circle is a circle that fits perfectly outside of the triangle. So like so, where the 3 points of the triangle are all on this circle. And the circumcenter is equidistant from each of the points of the triangle. So this is going to be congruent to this length, which is going to be congruent to MB. Because they're basically all radii of the circle. Lastly, we have altitudes. And altitudes, with their point of concurrency is 3 altitudes in a triangle, and it's called orthocenter. So orthocenter is the point of concurrency of 3 altitudes in a triangle. So this would be the orthocenter for this triangle. And there's no significance on its own with altitude, with orthocenters, but you can kind of remember ortho as being perpendicular because basically it's 3 perpendicular lines that create the orthocenter. And soon you're going to hear something called orthogonal, which is also something that is perpendicular. Okay, so now let's turn over to the back side and let's take a look at the medians. So first, remember that, first let's just identify the centroids of the 3 triangles that we created before. So, and the acute triangle, it's here. And the right triangle, it's there. And in the obtuse triangle, it's there. So it's basically the point of concurrency of the three medians in each of the triangles. Okay, so the medians create the centroid. Now, the other thing with centroids is that the centroid is twice away from the vertex as it is from the opposite side. So we can create some problems around this. So let's say we know that the length of AM is equal to 8. That means we can figure out what MX would be equal to. We could say that since AM equals 2MX, and AM equals 8, so we can say 8 equals 2MX. We can divide by 2, and we get that 4 is equal to the length of MX. So we can say that this is 4. Let's say we know the length of this segment is 3. Well, since this has to be twice as small as this length, we know that this length would be 6. And then also, let's say we know that the length of the median is 15. We know that it's basically that this has to be 5. Oops. This has to be 5. And that this part would have to be 10. So that the median is twice as far away from the vertex as it is from the opposite side. So we can kind of solve problems that way as well. So that's medians. Medians create centroids, and centroids are twice as far away from the vertex as they are from the side, and they're also the center of gravity. Next is altitudes and orthocenters. So the orthocenters are basically where the altitudes meet. So here are the points of concurrency. And so with right triangled, it actually ends up being the vertex of the right angle. That's the orthocenter. And then for obtuse triangles, the orthocenter is actually outside of the triangle. So with acute, they're inside the triangle. With right, they're on the triangle. And with obtuse, they're outside or on the exterior of the triangle. And altitudes don't really have any other purpose for now. Next section, you'll see the purpose of orthocenters, but for now, basically, orthocenters are the point of concurrency of 3 altitudes in a triangle. And then angle bisectors. So the point of concurrency for angle bisectors is called the incenter. So here is, let's see, how did it is? Okay, so here is the incenter. And then the incenter is the center of the inscribed circle. So you can create a circle that perfectly touches all 3 sides of the triangle once. And then also that this point, this incenter, is equidistant from all sides. Boom. But note that the distance that you figure out is not necessarily the angle bisector itself. Usually it won't be that distance. So we can say that that's congruent to that, which would be congruent to, say, that. Okay? And so we can do the same thing for here. So here would be the end center for a right triangle and an end center for an obtuse triangle. So the end centers are always inside the triangles, or the interior of the triangles. Lastly, we have circumcenter. So that's where the perpendicular bisectors meet. So with acute triangles, we get, it's the point of concurrency, so it'd be right there. And remember, let's see. So here are all the points of concurrency. Boom, boom, boom. With obtuse triangles, the point of concurrency is always outside. With acute triangles, the point of concurrency is always in the interior. And then the circumcenter for right triangles can be inside, on, or outside, depending on the length of the legs. Now, the other thing is that the circumcenter is the center of the circumscribed circle. So here is the circumscribed circle, and what we can do is we can draw a line, boom, and that's equidistant. I can draw a straight line, equidistant. So all of these are the same distance. Okay, so that point is equidistant from the three vertices of the triangle. And we can do the same thing for a right triangle and for an obtuse triangle. So like this circle will continue on outside of the realm of the PowerPoint. Okay? So those are the four centers: end center, circumcenter, orthocenter, and centroid. I wish you guys the best on the online quiz, and then come to next class, so that we can start doing the applications. All right, have a good one. Bye-bye.